Hello everyone. In this video, we're going to be solving an exponential system of equations. We have x to the power y equals y to the power x, and y is equal to 4x. Now, we're going to be solving for x and y values, obviously. Find out how many solutions there are, and what are some of the conditions. Now, we've done a similar problem before. Actually, it was without the second equation. So let's go ahead and think about it for a minute. What would happen if you were only given the first equation, x to the y equals y to the x? Are we going to be able to solve it? Sure, with some parameters, we can attempt to solve this problem, such as we can try to replace y with something like kx, which is kind of like a change of variables. So we're assuming that y over x is k. I'm not necessarily saying k is a constant, because k is usually used for constants, but in this case it's just a different variable. So if you replace y with kx, you get the following: x to the power kx equals kx to the power x. And then of course this brings the fact that what happens if x is equal to 0. So we kind of run into an interesting situation here, which is 0 to the power 0. Do you think 0 to the power 0 is well defined, or is it undefined? Or is it indeterminate? There's a lot of different terms, but if you look it up, Wikipedia is going to tell you that it's either defined as 1 or left undefined, depending on the context. So it really depends on who you ask, but it looks like there seems to be an agreement on this being equal to 1. If you look at the graph and look at the limit, of course, limit is a different thing. We're looking at the exact value here. So limit is a different story here. But anyways, suppose x equals 0 satisfies this equation, because 0 to the power 0 equals 0 to the power 0. What happens if x does not equal 0? Then we're allowed to cancel out the x's, can't we? Right? We can go ahead and get rid of these x's. If x does not equal 0, then we can write this as x to the k equals kx, divide by x, x to the k minus 1 equals k, and then raise both sides to the power 1 over k minus 1. And you get x in terms of k, which is k to the power 1 over k minus 1. Okay, great. So now, this gave us x, but what about y? Well, we can easily find y because we already assumed there is a relationship between x and y, which is given by this equation, y equals kx. So y is just going to be this x times k, but it's just going to be k over 1, k to the power 1 over k minus 1 times k, which is k to the power 1. And if you go ahead and add 1 over k minus 1 plus k minus 1 over k minus 1, because that's what 1 is, right? And then you're going to notice that the negative 1 and positive 1 cancel out, and this gives us k over k minus 1, which can be written as now y equals k to the power k over k minus 1. So let's go ahead and take a look at these two equations. Let me go ahead and copy x here so they can be closer. And now let's go ahead and explore what is going on. So now notice that y is k times x, right? According to what we assumed. But also y can be written as something else. Take a look. K to the power k over k minus 1 can be written as k to the power 1 over k minus 1 to the power k, because the exponents are multiplied. And k to the power 1 over k minus 1 just happens to be x. Therefore, this is equal to x to the power k, but this is y. Wow, interesting, right? Y is not just kx, but it's also x to the power k, which kind of gives us another relationship between these two variables. So we could also assume that y could be written as a power of x, and then plug it in, and guess what? We would come up with pretty much the same solution. Okay, great. We did everything without the second equation. So now replace k with 4, and you'll get your solutions, right? Let's go ahead and try it. If k is equal to 4, then we're going to get y equals 4 to the power 4 over 3, which is 4/3, and x is going to be 4 to the power 1/3. So it looks like this is the cube root of 4 to the 4th power, which is going to be 256. I believe that can be simplified. And this is going to be cube root of 4, because 256, actually, you can also do it with the exponents. 4 to the power 4/3 can be written as 4 to the power 1/3 times 4. So this is equal to 4 times cube root of 4. And of course, this is x. And as you notice, since k is equal to 4, y is going to be 4 times x, because y is equal to k times x. Make sense? Okay, so that's pretty much what the solutions look like, right? But let's go ahead and rewind and attempt this equation, the system, using both of these equations, and see what happens if we get anything different. So x to the y equals y to the x, and y is equal to 4x. By the way, this gives you a specific set of solutions. If you're not given the second equation, y equals kx or y equals x to the k are not the only ways you can substitute. Are there any other values that you can find by using different substitutions, or are all the solutions rational in that case? Anyways, those are good questions. Let's go ahead and leave them open and continue with this problem. So now, since we were given y equals 4x, we can easily substitute that in two places, and that gives us x to the power 4x equals 4x to the power x. Awesome. Now, again, we run into the same problem. If x is equal to 0, then 0 to the power 0 equals 0 to the power 0. If you're going to assume or accept the fact that 0 to the power 0 equals 1, then you're probably going to accept that 0 to the power 0 is equal to 0 to the power 0, which is itself. Anyways, if it's undefined, then can something undefined equal undefined? That's another question. But anyways, let's just get that out of the way and just cross out the x's. And this gives us the following. X to the 4th equals 4x. And now let's not cancel out anything. Put everything on the same side. Take out x. And then you'll get an interesting polynomial in factored form. From here, we get x equals 0 again. Wow, it keeps popping up, so we really have to pay attention, right? Well, if x equals 0, then y equals 0 automatically follows from this given, right? Now, what about the other part? If x cubed minus 4 equals 0, obviously, this gives us a single solution, x equals cube root of 4. Okay, great. So now, what would happen if x and y are allowed to be complex numbers, right? Then in that case, you would have a very different scenario. So let's go ahead and take a look at it real quick, and then we'll finish up with that. So after the substitution, we got x to the 4x equals 4x to the power x. So we can kind of think of it as x to the 4 to the x divided by 4x to the x equals 1, as long as x does not equal 0. In this case, we have to assume x does not equal 0 because we don't want to divide by 0. That's totally not allowed, right? Okay, now, what do you do with this? We have a common x, so we can kind of try to take it out and then simplify the inside. Again, assuming that x does not equal 0, we get x cubed over 4 to the power x equals 1. And then the fun part begins. You can go ahead and set this equal to a complex number. In other words, we're going to complexify this. We can write it as e to the power 2 pi ni, which is basically what 1 is in many forms. And then natural log both sides. You're going to bring the x to the front, so it's going to be x ln x cubed over 4 is equal to 2 pi ni. So if you have an imaginary number on the right-hand side, ignore that for now. Focus on the left-hand side. If you can put it in the Lambert's W function form, which is t e to the t, then we should be able to w this, and that's going to give us t. Remember, Lambert's W function is the inverse of t e to the t, which is going to give us the input, right? When we input the output. Okay, that kind of sounds weird, but I hope you get what I mean. But I do need an x cube, obviously, right? So it would make sense if you cubed both sides, right? But isn't that going to bring an ln cubed? Well, we could probably deal with that because we could kind of write everything. We could cube root both sides whenever needed, right? So you could go ahead and cube both sides, and then that's going to give you this cubed equals this cubed, so on and so forth. Now here's a $1 million question. Are we going to be able to solve it using not Wolfram Alpha, Lambert's W function? I'm going to leave it open and leave this problem at this point. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.